So just to kick off, I'm Tony Sullivan. I'm one of the committee members for Home Counties North East, and I'd like to welcome you along to this seminar. It's going to be given by Graham Wright from Dakin. He looks after part of their research and also looks after their compliance and legislation in the UK. And we're going to have a look at sort of the legislative changes that have happened, I think, pretty much since Brexit, and what will be forthcoming. Just a couple of housekeeping bits. If everyone can mute their mic and turn their camera off, which everybody has, that's great. If you've got some questions, please type them in the chat box, and we will pick them up. You can do that as we go along, and we will sort of pick those up at the end and go through those and deal with them. So can I just hand over to you now, Graham, and kick us off.
Okay, thanks, Tony, and thank you for inviting me to present on what is, shall we say, a bit of an interesting topic at the moment, because most of what I'm talking about today is yet to happen. So let me start sharing my screen. Let's make sure everyone can see what I'm going to present, and just 1 second. Fine. So, as Tony said, my name is Graham Wright. I'm a manager at the Environmental Research Group in Dakin. I actually operate in the UK. For my sins, I'm working quite a bit with government. So just to give you a little bit of background, I'm currently working with BEIS and have been working with BEIS on the heat and building strategy. I'm working with MHCLG on, or Levelling Buildings as it's now called, or DLUC as the acronym seems to have appeared, on skills and mandatory technical competencies. I'm also working with DEFRA on the F-gas regulation. So some of what I'm going to say today is, how can I put this? It is my view on things, but also some of it's a bit of a guess. So hence the crystal ball. I like to think I'm more of an engineer than a clairvoyant. So I've tried to keep this to the facts that I really know. We could disappear off in all kinds of hyperbole and try and figure out where things are going to go. So I'm just going to look at the following areas. Okay, so the first thing I'm going to do is take a look at building regulations. Now, I'm kind of assuming you guys are all waiting with bated breath to see the next version of building regs. There's also the heat and building strategy, which was published last week. I'm also then going to take a look at building safety bill. Now that is going to be a game changer for us, but it's going through Parliament at the moment, so there may be some change to do to that. I'm also going to take a look at product standards as well. Again, significant changes since we've left the EU, and quite frankly, some of the things that are going on within product standards at the moment could be a bit frightening in the future, but we'll have to wait and see how things move on. So building regulations. So there are obviously lots of versions or lots of regulations within the building regulations, but not many people actually realise it's the Building Act 1984 that gave us the way forward for looking at things like Part L, Part F, Part G, etc. That is the mechanism, that is the regulation that allows us to publish these documents to give us guidance on how to put buildings together. It's in itself is going to be looked at. So as you can see, 1984 is a long time ago. In fact, I got married in 1984, so that's that's quite some time ago. And when we start to look at building regulations, we know that there has been, shall we say, a significant iteration over from 2006 onwards through to 2010, where we looked at the systems approach to buildings. Then there was an incremental change in 2013. Now that was the last time government actually published anything to do with building regs. There have been some slight changes that have been going on. There was a study carried out in 2016 which basically said they didn't have to do anything in terms of regulations. So the building regs themselves, both domestic and non-domestic, really need to be looked at. There is a plan, would you believe? And the plan was that there was the Future Home Standard, which part of our building regulations were going to be published in 2020. That looked at the Future Home Standard itself. It looked at commercial buildings. It was looking at overheating as well. It was also looking at a bit of cooling. Now, there was also another plan to do something in 2025 and then look at further versions of Part L in 2030. The government had actually put together a strategy where they were going to start to look at things every 5 years, which is good news as far as I'm concerned. The problem is it's not 2020 anymore. It is actually 2022. And that, sorry, so there's 2021, and we can expect the building regulations to actually be published probably around about April 2022, and then come into force in October 2022. So to be clear, the reason for the delay is the government can only publish statutory instruments in defined time periods. So when you look at this, we've already missed the deadline for coming into force for April next year. That was the 5th of October, by the way. They should have published the regulations or the building regulations Part L, but they in fact have missed that date. So we expect that the building regulations to come out in the spring of next year with an enforcement date of around about the 5th or the 6th of October next year, because it's a statutory instrument. There are a couple of interesting things that have happened. The first thing you can do is say goodbye to the non-domestic compliance guides and domestic compliance guides. A lot of that information has been brought into the building regulations. That's quite interesting because there's a lot of techie stuff inside that was inside the compliance guides. So it's now inside the building regulations that won't be able to be changed until they do another iteration, which, looking at the way things have been delayed, we would expect the regulations to be out in 2026, possibly as late as 2027. So there's a significant delay going on there. There is a plan, as I said. There is a key policy timeline that is moving out. It's just shifted slightly. So, we're looking at building regulations coming out in 2022. The next version will be 26, 27, possibly, where we're looking at the end of high carbon fossil fuel usage and scrappage schemes to come in place. So you've seen some of that happening with the the regulations that have been published last week. The Future Home Standard, probably 2026. We're going to expect all new homes not to be allowed to install gas boilers or high fossil fuel devices, probably with the preference to heat pumps and other renewable technologies. Probably 2030 or thereabouts, we can expect phasing out of high carbon heat on grids, and then all new heating systems to be low carbon by 2035. That's a fair stretch into the future. I think the government has set out their stall quite clearly at the moment. It just depends on how things pan out over the next 10 years as how far we get with this. The Future Home Standard was published last week. Again, that was probably 9 months late, but it's out now. It's designed. It's about a 200-page document, and there's been lots of. I think the government published around about 1,600 pages of information last week, so we've all been busily reading. But it's there to improve buildings with low energy performance and high carbon emissions. It's looking at future-proofing new buildings to avoid the need for later retrofitting. So if I look at someone's new home and the new regulations when they come out, you can expect there'll be like a mandatory requirement for a maximum flow temperature of about 55. Probably a mandatory requirement that you've got to use low carbon technologies. They're looking to adopt a fabric first approach to improve building thermal efficiencies, which I think is a really good news. But it does have its drawbacks in terms of overheating. They're looking to increase the performance of products and appliances, and looking to increase the building market by developing our technical expertise and expanding UK's manufacturing capacity and capability in terms of renewable technologies. A couple of bits that kind of stuck out for me is, domestic properties. There is the assumption that all new buildings will be classified as off-gas grid by 2024 or thereabouts. So this means that if you're putting in a new building or a new development and you don't have a gas main into it, that will be designated as off-gas grid, and you'll be expected to use low carbon technologies such as heat pumps in those developments. Of course, there will be some get out clauses if that's not possible for things like poor electrical supplies, etc. And then non-domestic, they're looking for a phased-in approach. Now, this is not a rule. This is kind of, they're going to consult on it, but looking at a phased-in approach to try and make the largest buildings low carbon as soon as they can by 2024, and then followed by smaller buildings from 2026. Now, I think we all recognise the fact that heat pumps have been used in all kinds of buildings for a very long time in the non-domestic sector, so I don't think there's too much of an issue with it. It will just become a bit more regulatory in terms of getting those buildings over the line in terms of what we need to do for building regulations and how we're going to adopt low carbon technologies such as heat pumps and other devices. Okay, so that was a quick review of building regulations. As I said, you can expect them probably early part of next year. We're coming into force in October 2022. Let's talk about the Building Safety Bill. Now, the Building Safety Bill actually came from the report on Grenfell Tower, to be honest. That was one, I don't know if anyone's read that or if you've seen any of the podcasts, but some of the things that went on around Grenfell Tower with the work that went in there on the refurbishment and some of the other devices that were put in there is actually quite shocking. And I think it's given the government a significant wake-up call. Of course, one of their answers is the Building Safety Bill. What they want to do is to try and make things as safe as they possibly can, not just during the design and construction phase, but during the life of the building. I mean, for instance, Grenfell Tower, you're probably not aware, but they actually lost the gas main isolation valve because it'd been buried during a refurbishment and no one knew where it was. Those kind of things are quite frightening. So the detail really is, it could be mistaken for suggesting that it only deals with high-rise buildings, but it doesn't. It deals with all buildings. There are special considerations for high-rise buildings or high-risk buildings, HRBs as they're being called. It tends to bring together three regulations, which is the CDM regulation, building control regulation and fire regulation, and puts them in a circle. You've also probably heard things about the golden thread, where you have a clear communication process of all the regulations and all the way a building has been designed, how the systems are being used and how they should be used. It will give the building safety regulator, now anyone who doesn't know who the building safety regulator is, it's actually HSE, Health and Safety Executive, and it will give them responsibility for building control functions. And it's, there are going to be some teeth to this, so we're being told. So you can see that there is a significant change that's going to come along about who's going to be responsible and who's going to be doing the work, etc., and how the skills for the people who are doing the work will be monitored and assessed. I mean, that would be quite interesting. The regulation itself defines three roles. So this is where the CDM regulation comes in. You've got a client who's got to put out a specification about what they want. There is a principal designer, and this person will be responsible for all the design aspects of a building. That will get interesting in design and build, perhaps not so much in standard, shall we say, design processes where consultants are in for doing certain sections of a building or certain sections of a design and then moves on to the actual construction. And there will be a principal contractor. Now, the principal contractor is also quite a responsible role because it has to make sure, or he or she has to make sure that what goes in is actually being put in properly and is being commissioned properly. Under these regulations, individuals will need to have the skills and knowledge and experience and behaviours necessary for their role. That means their skills will be assessed. You just can't turn up and say I'm going to be the principal designer or the principal contractor. You've got to have the system has got to be put in place to say that I've actually got the skills and the qualifications for doing that. And of course, something being a member of CIBSE would allow you to say I've got the skill set to become a principal designer. And organisations have to have the same quality or the same capability. So you just can't make up an organisation and say I'm going to become the principal contractor for this thing. You've actually got to have a set of skills in place within your organisation to enable you to do that work. So it's going to be interesting. I can see there's going to be a fair amount of debate about who's doing what, where and when. And then you could even say, well, what about organisations like Daikin when they offer advice to people about what system needs to go into a building in terms of heating and cooling. And that's going to be an interesting question. That's something we need to deal with, and how we deal with consultants in the future. I don't think things are going to change. I mean, obviously Daikin has a very clear set of principles that we offer advice. It is the designer's responsibility for taking that advice and accepting the fact that that advice is sound, but we can have a bit of a debate about that afterwards. So the passage of the bill, it's already started, it's in committee stage, so there's not much detail here. There are lots of things online. In fact, there's a link in one of the slides that takes you to where the regulation currently is. So there could be some changes. We can expect it to be in place for the end of 2022, because the building safety regulator will take their position as of 2023, so at some time during that year. Big changes with the building safety bill. I can see it revolutionising our industry. I can see it making skills the centre and the responsibility of designers and contractors to fulfil their requirements to ensure that a building is handed over in a good way. And let me be very clear about it. I'm not suggesting that anyone on this call tonight is doing a bad job. I just think that there are a few projects out there that are bad or could be deemed as being bad, and one of those was going through tower when it was high, and the investigation has clearly highlighted that. So let's move on to product standards. Now, product standards are, excuse me, I couldn't help but put this photograph in. A nice picture of the Daikin piece of equipment next to a piece of Mitsubishi heavy industries equipment kind of sets it out for me. The products are the same in many respects. Yes, they've got different features in some ways, but in essence, there you've got two heat pumps, obviously cooling or heating a particular building. But to make sure those products are safe, we have to look at product safety. Now, when we left the EU, that moved from CE marking to CA marking, and there are deadlines in place to ensure that the CA marking is in place. There is energy-related products information that says that you're guaranteeing the performance. That's kind of tied up with eco design. Sorry, is someone? I just heard myself speaking there, so okay, I'll carry on. Then there is product standards. So we're talking about things like EN 378 and the standards that Daikin use to make their equipment to ensure they're safe. And then you've got things like the F-gas regulation, making sure that refrigerants we're using are being phased down in a controlled way, but we're all moving to a lower global warming potential refrigerant. So the next section is going to cover all of those in a little bit of detail. So when you start to look at, manufacturers have been, shall we say, in debate with the OPSS, which is the Office for Product Safety and Standards, and with government. But when you look at the products that people like Daikin supply and also other manufacturers supply in that space, boilers, etc., radiators, they all fall under one of these categories. They're either actual magnetic compatibility, pressure equipment, gas appliances, machinery, eco design, or low voltage. And government didn't make it easy for us. So previously we would have a certifying body that we would work with in Europe, and they would certify our equipment and put a CE mark on it. Government, when we moved over to CA regulations, said that organisation now had to be located in the UK, and that it would need to have certain authority to look at the testing and the data that we've been using for CA marking. As far as Daikin is concerned, it's a fairly straightforward transfer from one to another, but we're working with a certifying body that will, or an awarding body as they're called in the UK, that will give us our CA marking. There are some hotspots. If you're working with heat emitters, government have actually basically said at this moment in time you need to retest all your heat emitters. And when I speak to BSRA, they're talking about 67 years worth or 66 years worth of testing needs to be done next year. So there's going to have to be a little bit of, how can I put it, give and take on how that works. As I said, from a heat pump manufacturer perspective, I think it's fairly straightforward, and the government were kind enough to give us a delay, because the deadline for this was actually the 1st of or 31st of December this year, but it's now been moved to the 1st of December next year, or the 1st of January 2023, when people will have to use a CA mark. And on the slide there, you can see what a UK CA mark looks like. So that's one of the fairly sizable issues that we've been struggling with as an organisation over the past few months. The next one is eco-design and energy labelling. Now, the UK started its own review of ERP and eco-design at the beginning of this year. It didn't focus on anything particular, but there's also work going on in Europe. So, for instance, you can see here that we've actually got a label that's saying it's some product is category B. And from a UK perspective, you can see there's a nice Union Jack in there. That is the design that is now legal within the UK. It was actually legal as of June, but I think there's some dispensation been given, so people will either put it on the box or in the box up until Christmas, and then it had to be applied to products that are being labelled in showrooms, etc. There's some significant work going on with it. I mean, I don't know if anyone's tried buying a TV these days, but 2 years ago, all the TVs were A rated. Now, all the TVs are now F and G rated because the whole band of energy efficiencies has changed. And the same sort of thing is going on for heat pumps. So what may be an A+ heat pump now will turn into a C grade heat pump in about a year or so's time, because they've created a bit of headroom for more energy efficient products. Interestingly, there is an assumption by regulatory bodies and government that there will be continued efficiencies. I'm not quite so sure, but hey, we'll see when we get there. And they've also tried to simplify it. There's one kind of rub though, that if we apply our energy label to a product here with a Union Jack, it's now not acceptable back in the EU. We have to rip the label off and now stick the EU label back on, because apparently people in the EU are confused by the whole situation. So you can see there's a bit of give and, or not so much give and take, but there's obviously a bit of friction there between the UK and the EU around this subject. But lots of changes in the future. There is the risk that the UK could disappear on its own trajectory for things like eco-design and energy labelling, and that could be a significant problem for us, because you would end up trying to make two different types of product, one for the EU and then one for the UK. But they're the same for the foreseeable next 2 to 3 years. Thinking about product standards now, the UK actually lost its role within Europe when we left the EU. We were actually quite a prominent body within the EU regarding EU regulations, but CEN, the global standard, has allowed us back in. So we still have a voice. I wouldn't say it was as loud as it was previously. Had quite so much influence. But it still means that we're around and we can have a say during the regulations, unlike things like ERP within the EU. I put this slide up so that people can understand where we come from as an organisation with standards. So you will find that all of our products are generally made to IEC regulations, in particular IEC 60335-2-40, and you'll see that mentioned in our installation instructions. It's actually quite important that you follow those installation instructions. ISO standards, the one I've mentioned there is 5149, which deals with refrigerants, and EN 378 are generic standards, and the IEC regulations actually carry precedent over EN 378. So for instance, when we do a pressure test on our installation manual, we will actually tell you what to do in terms of a pressure test on site, and it will be based around what's needed for the IEC regulation, whereas an EN standard may tell you something slightly differently. Interestingly, if you don't have any information on a product, you can immediately move to EN 378 in terms of refrigeration, pipework, etc. It's kind of interesting nuance, but in essence, the message I'm trying to give to you here is very clearly follow our installation instructions as closely as you can. Any deviation and can cause problem in the future. And that kind of brings me nicely on to the last subject that I highlighted, which is the F-gas regulation. We left the European F-gas regulation when we left the EU, so DEFRA are in a process at this moment in time of going through what will become the UK regulation, and it will be different from the EU regulation. I have to say, DEFRA are going through a very defined process. So we have meetings with them every 6 weeks. There's about 30 people on the working group for air conditioners. The graph just came from the last presentation, and they're looking at the cuts that are going on, and they want to try and make more of a cut towards the late 20s, so 27 and 2030 if they possibly can. But they're very clearly stating that actually, rather than focus just on the global warming potential of a gas, they want to focus on the efficiency of a system, and then how we can make sure that refrigerant remains within a system over its lifetime, and then move to a lower GWP gas after the 2030s. There is a good possibility that the F-gas regulation may also be extended for past 2030, but it's a bit of a debate at the moment. So as the slide suggests, we're between July and December, there's a consultation process going on. There will be a stakeholder review taking place between January and May 2022. They will also write and publish in that same time frame. The final consultation will go into October 2022. And the regulation will be passed into law. So again, it's the same kind of time frame for building regulation. So you can say that the F-gas regulation will be out in October 2022, but actually come into force, we think, between April and June 2023, depending on how things move on. It's going to be interesting, but I can honestly say that the DEFRA are doing a far better job than the people in the EU, who seem to be in 2 or 3 camps at the moment, from ultra green to people who say let's keep the status quo. So I'm not suggesting that we're anywhere near that kind of debate at the moment. It seems to be a very positive discussion. And refrigerants like R32 and R410A look like will still be used well past 2030, but they've got to be used in the right way. And there will still be the use of recycled refrigerants as well. I realise I've kind of sort of spouted that off fairly quickly at people, and I'm sure there will be some questions. So I'm going to stop sharing my screen now, and let me see if there's any questions that we need to respond to. Thank you very much.
Graham, you might be able to unmute yourself now. Apologies for the interruption.
That's all right. You gave me a heart attack. I thought I'd been muted all the way through that.
No, and I'm just bringing up, I'm afraid, Jared, you are not appearing. Apologies, everybody, for the interruption. But Graham, you should be able to see the chat box.
Just looking for it now.
Can you see it at the top of the screen? Otherwise, I'm happy to put the question for you while I get Jared back on the line.
Okay, fine. So I've got a... Yes, Fiona Fanning has asked, will the presentation be available? The answer is yes. Although there is a date on it, and it might go past its sell-by date as things move forward. So it's good to see. It will be good to share that with you. And I think Philip Jordan has asked, please, how is gas safety guarantee as the existing 29 million homes and 2 million non-domestic buildings switch from gas use? I don't know the answer to that, Philip. I know the gas safety regulations are not under review at this moment in time, so I can't really answer that one, unfortunately. Trying to scroll down. Hold a minute. Let me just.
Tony, you should be able to unmute yourself now. Thank you.
Okay. I'm quite happy to read them out for you.
Would you mind?
Yeah. So the question is: are the supplier manufacturers catching up with F-gas regulation? There are a lot of AC products out there that runs with the refrigerant that will. That will be phased down when this is mentioned. Clients compliance moves away. So I think it's it's really about those changes in F-gas with regulations and the refrigerants.
Yeah, I think that we need to make a clarification between what's going in and what's installed. So there was a case in point, and it's worth mentioning here that there are still people specifying chillers with 134A in them. Why? I don't know. It doesn't make any sense. So what I would say is that as you specify a machine or a chiller that's going in or a system that's going in now, you need to specify it with a refrigerant that's got as low a GWP and as high as efficiency as you possibly can at this point. If you have a machine that has currently got, should we say, R407C or 134A in it, there needs to be an understanding of when that machine will be removed or upgraded so it uses a lower GWP gas, and when that happens, what happens to the refrigerant that comes out of it. So you're kind of in a situation where if you're specifying, shall we say, an R410A VRV system at this moment in time, which is still available and they're still being used because of the efficiency, there will still be refrigerant that will be available through the phase down process. That refrigerant will tend to be either new refrigerant, which is very unlikely, or will be recycled gas. Do you see people like Daikin actually supplying their equipment these days with a recycled R410A? You'll see other manufacturers begin to do that as well, because there's still a lot of gas out there that we can reuse. We just need to make sure that we are reusing it in the right way. As we move further forward, closer to the phase down, products will become available with even lower GWPs, and we'll all move to those in what I would call an orderly fashion, rather than just a dash to the gas with the lowest refrigerant or lowest GWP that might not be quite as efficient as it needs to be. Long answer, I'm sorry, but yeah, it's a bit of a techie question.
Yeah, I might just put one of my own in there. There was a few stories knocking around at the sort of middle of this year that there'd be quite a severe reduction in what was permitted in terms of GWP on the F gases, and people were sort of moving or saying you might have to move to things like propane and R290 and the R600s and those sort of refrigerants. And I did wonder whether the question that asked about gas safety, perhaps related to that as well. There's quite a bit of R290 going in, normally in seal machines and that sort of thing, into people's homes. Yeah, what we think about that.
You're quite right. If I may come back, Tony, on that one, it's quite interesting because when the IPCC put their report out this year, they put the GWP of certain refrigerants up, and everyone thought it would be a problem. So the F-gas regulation measures the GWP under the 4th IPCC report, and it's fixed. Because if you were to change it, you'd end up recalculating all the allowances that you're allowed. Now, the use of hydrocarbons in systems is actually quite interesting. As we all know, R290 and propane are the same thing, basically. One's just slightly physically drier than the other, but they both burn very well. And putting those into, shall we say, split systems or even more complex DX systems will be quite a process. And yeah, safety would play a massive part of that. But when you think about what I was saying earlier in terms of homes, there's a good chance that we'll be able to use propane or R290 in heat pumps for people's homes, because the charge sizes will be relatively low. It will be in a monoblock system, and it will probably be the biggest user of HFCs that's coming up. We know what's going on with the market as it currently stands. So I think R290, perhaps not R600, will become part of what we do in the future, but it will be mainly in monoblock systems and smaller charge sizes.
Okay, we've just got some more questions that have come in. So says, great presentation, Graham. Good to see you. Well, in your opinion, how will the proposed building safety bill affect A, DMB projects, and B, the general timelines of construction companies to deliver versus the target of homes required to be built yearly, and see the level of subcontracting for different building services, which will usually takes place currently and unfortunately can heavily impact quality of final products on handover. Many thanks, he said. That's Georges.
Yeah, good evening, George, and thanks for the awkward question, because probably the design and build section under the building safety regulations is going to be the trickiest. I can't give you an answer to that, how that will work out, but I think the criteria for the people in place or who are going to take the responsibility will remain the same. It's just going to depend on who's doing the majority of the work. I don't want to say much more than that because I can't give you a straight answer.
Okay, got another question, which is from Colin. He asks, will standards such as British standards have a testing and approval scheme attached to them?
I don't think you're going to. There will be British standards, but the vast majority of the standards that you will see appear in the UK will still have some European content and global content to them. If you know, basically, why would you create a British standard if you can use a global standard, an IEC regulation, shall we say, or a European standard? The only time you're going to get a British standard is if we're doing something specifically for ourselves. So if I look at standards that we use, so the IEC regulations looks at safety of the product, but if we look at performance, we're looking at standards like 14511, EN 14511, and also seasonal efficiencies, EN 14825. So, you know, they are still being adopted and used within the UK at the moment, and that's where your products will be tested too. Could we do something different in the future? The answer is yes. Should we? Probably not. But you know, again, I'll get my crystal ball out and polish it a bit harder to see if we would do something like that. Not so sure we would.
Okay. Nick says he's not a specifier, so he's a little behind the current refrigerants available. But he asks, what are the refrigerants that are in use today and likely to be around in the next 10 to 15 years? Or is refrigerant technology developing year on year?
I think year on year would be lovely, but I think we all recognise the fact that if someone was to get out their chemistry set now and create a new refrigerant with a very low GWP, you're probably looking at 7 to 10 years before it becomes commercially available, and probably another 5 years on top of that before it was being used in equipment. And I say that because I was around when we moved to 407C. I was also around when we moved to R410A, and R32 has been a bit of a direct use for us because it's very similar to 410A. And quite clearly that's taken a bit of time to get off the road. So we've been using it on split systems for 5 years. You're going to start to see chillers and also VRF and VRV systems start to use it in the not too distant future. If we were to currently use some of the very low GWP refrigerants, shall we say an HFO gas, which has got a GWP of 1 or 3, or depends, it's below the 150, below the 150 number that people, the magic number that people are aiming for, it would be a significant redesign of equipment. And one of the reasons it's not been done is primarily because equipment would get a lot larger, and we'd have to go through a whole change of over a period of time to make systems as efficient as they currently are. So 10 to 15 years is about the lifetime of a system of a gas. And don't forget, it's not just, it doesn't get stopped at that point, it moves on afterwards through what is a phase down tail. So if you think about R22, we've basically got to the end of the phase down with R22, although I'm sure you guys have probably seen some systems out there that are still around using that refrigerant.
Okay. I don't know if I got that pronounced that correctly. Asked, says, how about the impact of heat pumps on existing electrical infrastructure? If there is huge interest and everyone wants to change their fuel type from gas stroke oil to electricity, would that not increase demand that the current infrastructure can cope with? Plus, the heavy intake of electric cars that are expected in recent years and other environmental factors. Should the government also encourage other technologies as well as heat pumps?
Yeah, I understand the question. All I'll say to you is that the government wants us to go and buy electric cars, and they're going to have to invest on the infrastructure to enable us to charge up electric cars. Now, we're talking about load demands, we're talking about demand side response, turning down your heat pump if there's not enough electricity, turning it up if there is too much. You know, there's all kinds of things that are being done, but I recognise the fact that the government will have to increase the electrical infrastructure within the UK to enable us to use all this electricity. So, yeah, yes, you've got that, but, and that needs to be looked at. You also got to face the fact that the average COP of a heat pump these days is 3 to 1. So we've got 1 kilowatt of electricity going in versus 3 out. We could debate that number if you wish, but I mean that's the kind of number the government is using. But there has to be something done about the electrical supply infrastructure. I would agree.
Okay. We got another question came in there. It says, will there be an equivalent of the CIBSE rating for heat pumps to help police poor quality units being sold?
It's already in place. It's called the Energy ERP. What happens is the manufacturer has to declare their performance of their heat pump, whether that's a commercial or a domestic heat pump. That performance has to be guaranteed, and the UK government has the Office of Product Safety and Standard, who will go along and check heat pumps. So, for instance, this year they did a desktop study on heat pumps. 2 years ago, they actually took some heat pumps to Denmark and tested them to actually prove that they were providing the performance they said they would. So, from a boiler perspective, you've got CIBSE. From a heat pump perspective, you've got Energy Related Performance Directive, which is the piece of regulation that we have to abide by.
Does that make any allowance for sort of defrost cycles and that sort of thing?
Yes, it does.
It does, does it? Yeah. It does.
But you'll also find that heat pump suppliers or reputable heat pump suppliers will send you integrated performance data. We all know that the worst time to run a heat pump is from about +5 down to about -3 or 4, -2 being about the worst spot because of the amount of humidity in the air. And heat pump suppliers should supply you integrated performance data. And the integrated means that they've looked at the defrost cycle and told you how much capacity you're going to get out of the system at that point.
Yeah. There's another question come through, a couple of questions. Can a new Part L and NBD SCG have an impact on seasonal efficiencies of the heat pumps?
Currently, the non-domestic compliance guide was stating an efficiency of 2.5 for a heat pump, whichever heat pump is way above these days. I don't think the new number they're talking about is 2.8. It may make an appearance as the minimum criteria, but believe you me, if you're looking at a seasonal efficiency for a heat pump, it should be way above 2.8.
Yeah. Philip says, as gas use sinks, at what point does the gas grid become unviable practically and or economically? And what happens to those still on it and unable to use a heat pump?
You know, that's a very interesting question because no one knows the answer to that. All I'll say is that far in the future that I probably don't have to worry about it too much. But at some point, they will have, if heat pumps can become the de facto heat source for people's homes and buildings, the gas infrastructure will either be shut down or it will be reduced to the areas where they can't get enough electricity or they're using other gases. I'm very much an advocate that actually heat pumps are not the only solution. Hydrogen will be there. There will be systems that we're using, biomass. There'll be all kinds of things that are going on. And if we just point at one and say it's going to be heat pumps, all we're doing is we're putting all our eggs in one basket, which is never a good thing when you're looking at a policy for the country's future, and government are fairly open about that.
Yeah, I mean, I think there's been a lot in the press recently, and perhaps not very well informed comment in the press about the switch away from gas boilers, and I think I saw something like there's about 1.7 million gas boilers sold every year. These are domestic in the UK, and there's about 22 million homes that have sort of single gas boilers currently. A lot of people have systems that have, need high temperature water in order to work, and at least at some part of the year, I guess a condensing boiler, will work at a high temperature when it's needed and when it's not. But I don't know there seems to be plenty of low temperature heat pumps on the market, but not much in the way of high temperature. Do you think that will change?
The current criteria and this is being debated by DLUC or levelling communities at the moment, who are responsible for putting the building regulations out, is what do they do with new homes? So there's one case in point where they make the maximum flow temperature on heating systems in new homes at 55-degree flow. That might move to 60, but it's unlikely to. So that means all new homes from, shall we say, next year should have a heat pump ready system installed. So that means at least at that point we've got a line in the sand that we can all work to. What do we do with all the homes that have been built beforehand, the 22 million, and your 1.7 million homes boilers is correct? Well, we go through a very painful process of reducing the flow temperature in those by insulating them and changing the radiators, and that's kind of where we're at, and that's going to be quite a task. And as you say, 22 million homes is about where we are. Government have stated they want to be installing 600,000 heat pumps a year by 2028. That moving to about 1 million heat pumps a year by 2030. Considering we are probably going to be installing around about 60,000 heat pumps this year, I'm sort of having a bit of an educated guess because I've seen some market numbers. That's a massive change, and the heating industry needs to pick up the baton and run with it. And I've not seen anyone saying they don't want to do that at the moment. I think it makes sense, but it becomes a massive job. And really, the first phase of that is to get all new homes that are put in heat pump ready, or have a heat pump or some other device that is there.
Yeah, I mean, there's just another question, and I don't know whether you'd be able to answer this one or not, but I look at the cost of a heat pump, and I look at the cost of a large split AC system of a similar capacity, kilowatt rating, and I see a massive difference between them. And I don't see much of a difference, in what goes in them. And I wonder, that there is a huge worldwide market for split systems, and a lot of competition, and a lot of them are made. And I guess they're sort of, built to a price, and they are probably quite a bit cheaper now than they were, say, 10 years ago. I mean, do you think the same thing will happen to heat pumps?
So the going figures for heat pumps for a boiler at the moment is between £3,000 to £4,000 a year, and in fact, £3,000 to £4,000 an installation. And the going rate for a heat pump at the moment is being quoted as £10,000. So there's a significant difference in there. That's why the government have put an incentive into. So next year there will be the boiler replacement kind of incentive that came out of the heat building strategy, where they're spending £450 million over 3 years to put in 90,000 heat pumps per year in people's homes. I think we have to face a fact, and I'll paraphrase one of my colleagues. That people drop kick boilers in and don't think much about about design and what happens when a boiler goes into someone's home. I don't think that happens to all of them. It happens to some. So we need to be a bit more realistic about what we do with the boiler. And when we do that, the cost will go up for a homeowner to have their boiler replaced. And then we'll get into a situation where it will get closer to a heat pump. But I don't think, and also then the heat pump installation will come down because there'll be more installers in there, and the law of economics will take place where there's more competition, so the prices come down. But I don't think we'll ever get to a point where a heat pump will get down to about £4,000 or £5,000 a year very soon. It will take a period of time.
Okay, so we've got a few more questions coming. So should everyone involved in the design of a heat pump system calculate actual seasonal efficiency of the unit based on site-specific weather conditions and part load condition? Actual SCOP can be different than the SCOP steer based on test conditions.
I'm going to say the simple answer is yes, if you've got the data.
Yeah.
You know, if you're modelling what the performance of a heat pump is going to be in a big building, I would definitely be trying to do that. If it's someone's house, well, I would have an educated estimate. I'm not going to use the word guess as to what that's going to be, but I would definitely be looking at the way different equipment performance applies and what data is available from that manufacturer.
Okay. Yeah, Philip Gray makes the comment. I mean, you may have answered this. Says the government seems to think the cost of a heat pump will come down. Is this the view of heat pump manufacturers?
Yes, for the reasons I mentioned before. You might see a little bit of reduction in equipment costs, but you're not going to get a significant change. I mean, the government seems to be under some kind of belief that if you start putting 1 million heat pumps a year, the cost is going to come down. Well, the global market for air conditioners is billions of units, and we're already in such economies of scale that you're not going to get too much. So putting a heat pump together for the UK is probably not going to get you a cost reduction. But where you will see a cost reduction in many respects is if you insulate someone's home, their heat demand falls, therefore the heat pump size gets smaller. And then if at that point you'll start to see a reduction because physically you've got a lower heating load. So that's where things may happen. And as I said before, installers may well, shall we say, reassess the cost they're putting forward for installations when there are more people out there competing with them.
Yeah. Another question from Georges. How will the new proposed maximum flow temperatures for new homes affect the domestic hot water aspect of the heating system? As there may be higher storage temperatures required, will the no proposed regs still allow for an intermittent use of an immersion heater to cover that?
Okay, well, I'm very much of the belief that I would love the Health and Safety Executive to come out with some clear guidance for ACOPS L8. As they currently stand at the moment, for domestic, you can either run a Legionella cycle once a day or once a week, and this tends to be at about 60 degrees. So if you're running that once a week, you're looking at running your electric heater for probably 2 to 3 hours if you're using a cylinder once a week to act as a disinfection regime for your system. For commercial buildings, it becomes even more of a debate. I mean, past experience, I've seen someone rip out a heat pump and put several kilowatts of electric heating into a cylinder because a consultant suggested that's what they needed to do to ensure they didn't have any issues with Legionella in our system. So it's going to be one of those sort of situations where, from a domestic perspective, you're probably going to need to use some kind of disinfection regime, and from a commercial, you may need to understand how that's going to work for water storage within a building and how much water you're storing within your building. Most offices these days don't have massive need for water, large quantity of water storage, whereas things like hotels and gyms, etc., do. So it just depends on what you're doing. But 55 degrees C is not going to get you past ACOPS L8 at this moment in time, although it would do in France with their equivalent because they're using 50.
Okay, and another question. make a conversion of an existing heating system using boilers to heat pump systems also requires other auxiliary equipment to be used, such as thermal store, larger radiators. Does the government grant also cover the cost of other equipment as well? If the system is not properly designed, unit will cycle and not go into work or not as efficiently as expected.
Yeah, I mean, this thing about the boilers we put into our homes at the moment, they tend to be of the 30 or 35 kilowatt variety because they're not sized correctly. So they're working inefficiently, but they're working effectively. So if we were to size our boilers appropriately, we'd probably save ourselves a bit of gas, and therefore doing the same for a heat pump is going to give you a better result and make the system work properly and quite clearly not cycle, because cycling for a heat pump is really bad. It's bad for a boiler, but it's even worse for a heat pump. So in essence, sizing is crucial, and things like thermal stores and larger radiators will enable us to get to where we're getting systems work more efficiently.
Okay. One more question. Says, why is hydrogen not given far greater provenance for the massive number of existing homes using gas, saying 22 million, i.e. 75% of 29 million?
You're testing my grey cells tonight, Tony. I really are. Okay, so there are two types of hydrogen. There's the ordinary hydrogen that comes out of chemical reactions, etc., and basically is not very green. It uses a fair amount of electricity. Then there's the other type, which is what they call blue hydrogen, which uses renewable electricity. And so there are kind of two aspects to the answer to this. So you've got to look at where your hydrogen is being generated from. Okay, so yeah, if we accept the fact it's going to be blue hydrogen and generated by using renewable electricity, the sums suggest that you're going to get about 0.7 COP in terms of the amount of hydrogen you're going to get when it gets burnt at someone's home, because you basically can't get more than one, and by the time you distribute it to wherever you're going, it works out at about 0.7. I can't remember where that number came from exactly, but that's the number that's being used. Whereas if I take that 1 kilowatt of electricity that is, to take that 1 kilowatt of electricity that's being used for a heat pump, I get 3 kilowatts of heat out of it. So there's kind of an efficiency debate going on there. Then you move on to the infrastructure and whether the infrastructure is good or bad, and whether you can put hydrogen down there. Then you move into the cost of whether someone's willing to pay for a kilowatt of hydrogen, which is going to be more expensive. I think the fact is that we will use whatever system's best for the area. So there may be some areas in the UK that will use hydrogen. There'll be other areas that will use heat pumps. I don't think there's a right or wrong answer to this. So my feet is firmly in both camps. And I think that the LETI document has been put forward. And someone is just saying hydrogen is appallingly inefficient. All of these things are kind of true, but we need to let that technology gain some ground so we can start to use it. Quite clearly we are in a situation where we need all those eggs that are in our basket, because we don't quite know really what's going to work at this point in time, but we do need to act now to make sure that we're reducing the amount of carbon we emit when we heat and cool our homes and buildings.
Okay. I mean, my observation would be is that it's quite be interesting to see how much hydrogen costs if it's generated from electricity and it's less efficient. There is that efficiency drop off. It'll be interesting to see what it costs to get piped into our houses. There may be an economic argument to switch away from that just for that reason.
I've seen lots of numbers, and I'm not going to say them now because some of them are frightening and some of them supposition. So it could be all kinds of things, but we'll see where we are. We'll see where we get to when hydrogen becomes available as an energy source.
Yeah, let me just see if we've got any more stuff that's coming on. let's see. With the quantity of heat pumps needed, are there any plans to manufacture more in the UK? I don't know if there are any manufactured in the UK, are there?
Yes, there are. Mitsubishi Electric have a factory in Scotland near Edinburgh, making air-to-water heat pumps. Valent are looking to supply some, make some in the UK. It wouldn't surprise me if Worcester Bosch do the same. Have Daikin got any plans? Nothing I can mention here anyway.
Okay, that's fair enough. Yeah. Okay. I mean, I think Philip Jordan's pointing out that hydrogen can be used as a means of energy storage. If it's generated from wind.
Yeah.
I know, which is something a lot of countries are looking at.
I think if you look at our ambitions for wind, they want, I think, I can't remember the exact number, but we're looking at doing 4 times more than we currently do. So, I think wind is going to be, and if you look at a stormy night on some apps, you can see how much how much electricity has been generated from wind. I think it's going to be a significant contributor in the future, and I suspect there will be a significant amount of spare electricity around when the wind is blowing. So, energy storage, CO2 capture, all of those things are going to be part of the mix in the future.
Okay. Just looking through. Right. Well, I think we've kind of got to the end of the questions. I mean, I can see one hand that's gone up from. Let me just check. From Festus. I don't know if that's something that you. I'm not sure that I can unmute Festus. So yeah, but as did say at the start, if you've got any questions, type them in the box. That might be a hand that's been accidentally raised, perhaps. Let's just see if we've got more. Okay. Another thing says, would that not be easier for some people simply changing their boiler system with electrical radiators? The more the grid becomes greener, the more electricity will be cheaper. Would that not encourage people to choose electric radiators? I wonder if those if they're allowed in the new future home standards, direct electric, or.
It's allowed, but basically the government don't want to use it because if everyone moved to direct electric, we would definitely have to start building a few more nuclear power stations and plant a load more windmills. Yeah. It's not a bad solution in the right way, in the right application.
Yeah, I mean it is done, and I guess if you've got a highly insulated new dwelling, it's not so bad. But I know you can't do it on in London on sort of large developments that get called into the GLA. It's not permitted, and it's quite limited, really.
Yeah.
Okay. No, I think we've just about come to the end of it, and I think I will leave it there. There's some thanks that have come in on the meeting chat. It's very nice.
Yes, thank you very much.
Right, and I would just like to thank you, Graham. It's been a very informative presentation on the those forthcoming changes, and I think we've well and truly picked your brains on heat pump technology, refrigerants, and forthcoming changes in that area. So yeah, thank you very much, and thanks for attending. All of this will be on our Home Counties North East website, and Mohammed's put a link to that in the chat. And our next venue will be with Spaces, and that's next month. I don't have the date on me, but keep an eye out for the emails coming out about that, which will be an in-person event. And then we have monthly events running through the next 12 months. Some of those will be, most of those be online, but some will be in person. So just remains for me to say thank you very much for your time. That's much appreciated, and I wish you all good evening.